So let's continue, right? And dig in a little bit to when we're thinking about this triangle in these figures that we know are similar. Um, it says, what is the scale factor? Well, we know that the ratio of corresponding sides is called the scale factor. Okay, it's called the scale factor. So the scale factor here, we could then say, as we look at this triangle, it says, what's the scale factor of triangle ABC to, right? We could think of it like a comparison to triangle DEF. So the information from triangle ABC is going to come first because it's represented first in our proportion. So what is the scale factor of ABC? Well, let's pick a side. So the ratio of corresponding sides. Well, we know that AB is corresponding to side DE. So we can say there that the scale factor is 8. We're given that this side length is 8 to 12 of that same corresponding side in the similar triangle. So the scale factor is 8 to 12. Well, that can also be simplified. We could use a diva, right? We could divide them both. We could say we could divide them both by 4. So we can pull 2 4s out of 8 and 3 4s out of 12. So similarly over here, we can say then what's the scale factor if we say of triangle DEF first to triangle ABC? Well, let's just pick another side. We could say, all right, we have a 9 for triangle DEF. If we pick this side here, EF, we need to pick the corresponding side in our similar triangle. So that would be side here, BC, that is connected right to the same angles as in EF. It's connected to the single and the triple and the single and the triple. So we have a 9, 2, 6 scale factor, which can also be reduced. We could divide these both by 3. So we could say we could pull 3 3s out of here and 2 3s out of here, which becomes our scale factor. Okay. So when you then use this information, right, you could find the scale factor for this last one too, but what you'll see is that when you compare them, when you go from one to the other, right, we could have done this same 8 to 12 of the ABC triangle to the DEF. We could have also just flip-flopped and said, well, let's just do a 12 over 8. And you would find that you will end up, again, as you simplify it, with a 3 to 2 ratio, which is the same because all of the corresponding sides, right, whichever one you use, if you use the AB, which is in red, or the BC, or the AC that we haven't used, right, that we don't have a color for yet, it is going to, when the figures are similar, be the same scale factor. You just want to make sure that you're recognizing which triangle or which figure is coming first in your ratio.